Hello everyone, welcome back to Algorithm with Chelsea. Today, we will learn a classic coding problem called toSum. We will solve it using nested for loops in Python. Let's begin. Let's start with a real-world story. Imagine you have a pocket of coins, like 50 cents, 10 cents, 5 cents, 25 cents, and so on. You must pick exactly 2 coins, not 1 coin or 3 coins. The 2 coins must add up to a target value, like 50 cents. Which 2 coins would you pick? Now let's formally define the toSum problem. We are given a list called numbers. For example, it contains 2, 15, 7, 8. We are also given a target number such as 9. Here is the goal. Try to find 2 different indices whose items add up to target. An index means the position of an item in the list. 2 different indices means we cannot reuse the same position twice. If there exists such 2 indices, print true. Otherwise, print false. For this example, the output is true. It is because we can pick the number 2 and the number 7. 2 plus 7 equals 9. So a valid pair exists. Here is a different example. The target changes to 14. Numbers list is the same as before. Can we find 2 different indices whose items add up to 14? The output is false. You might think 7 plus 7 equals 14, but there is only one 7 in the list, so that would be using the same index twice, which is not allowed. Here is another example. The list numbers changes. Numbers now contains 2 7s. The target is still 14. This time the output is true. It is because there are 2 7s, and they are at 2 different indices. So 7 plus 7 is valid now. So how do we try all possible pairs? We can pick 2 indices each time. I is the first index. J is the second index. To make sure I and j are different, we make j start at I plus 1. In this way, j is always different from I. Let's discuss the idea in detail. Keep in mind that the goal is to find 2 different indices whose items add up to target. Let n be the length of the list numbers. We use nested loop. Outer loop ranges I from 0 to n minus 2. Inner loop ranges j from I plus 1 to n minus 1. For every pair I and j, we check the sum of the 2 list items pointed by I and j. If their sum equals the target, we know the pair is found. Now let's trace an example step by step. Keep in mind that the goal is to find 2 different indices whose items add up to the target. The target is 9 in this example. In the figure, the list contains 2, 15, 7, 8. Point I to the first item, 2. J starts after I. J points to 15. The 2 pointed items are 2 and 15. Their sum is not 9. Move J to the next. J points to 7. 2 plus 7 equals 9. Great, the sum equals the target. So for target 9, we found a pair. The output is true. Here's another example. The target is 14. It's different from the previous example. The number list remains the same. Point I to the first item, 2. Point J to the item after I. 2 plus 15 is not equal to the target. Move J. J points to 7. 2 plus 7 is not 14. Move J again. 2 plus 8 is not 14. Move I. I points to 15. J points to 7. 15 plus 7 is not 14. Move J. 15 plus 8 is not 14 either. Move I to 7. J points to 8. 7 plus 8 is not 14. No more pairs. So for target 14, we did not find any pair. The output is false. Here's the Python code for toSum. Let's read the code carefully, line by line. We are given the input list, numbers. It contains 2, 15, 7, 8. We are also given target equal to 9. We set n to the length of numbers using the len function. N means how many items are in the list. Then we create a variable named found and set it to false. False means we have not found the pair yet. Now the loops start. For I in range of n-1, it means I goes from 0 to n-2. We stop at n-2 because I must leave at least one item for j on the right side. Inside that, we have the inner loop. For j in range of I plus 1 and n, that means j goes from I plus 1 to n-1. So j is always a different index from I. Inside the inner loop, we use an if statement to check if twosum is found. If the numbers pointed by I and j add up to the target, then we set found to true. After all loops finish, we print found. In this example, list items 2 and 7 add up to the target 9. So found becomes true, and in the end, the program prints true. To make the logic simple, the loops doesn't break when the twosum pair is found. This is inefficient. You can actually make the program faster by using break. Let's add break statements to stop early. Once we found the pair, break the inner loop and then the outer loop. Look at the code. We add 2 lines of break statements. The first one breaks the inner loop, and the second breaks the outer loop. Look at the first if statement. It's inside the inner loop. When we find a pair matching the target, we set found to true. Then we break the inner loop, so j stops moving. Look at the second if statement. It checks if found. That means if found is true, we break the outer loop and stops I from moving. So with break, once we know the answer is true, we do not waste time checking more pairs. We directly stop the inner loop and then stop the outer loop. This program is equivalent to the previous one, but this version runs faster. Let's summarize what we learned. Twosum means, given a list numbers, find 2 items that sum up to target. We use nested loops. In the outer loop, range I from 0 to the second to last index. In the inner loop, range j from I plus 1 to the last index. The list items pointed I and j forms a pair. We check if the pair adds up to the target. If yes, the twosum pair is found, and we break the inner loop and then break the outer loop. This concludes our lecture. Thank you for watching. Please subscribe to Algorithm with Chelsea so you won't miss future updates.